look at derivatives. We are going to look at derivatives. Now, under these derivatives, we are going to look at what we call differentiation rules. Differentiation rules. So we are going to look at 6 of them. So 6 of them. So 6 differentiation rules. We are going to look at 6 differentiation rules. Okay. So the first we are going to look at is a derivative, how a derivative is represented. So number 1, we take derivative. Now we are seeing a function. We are seeing a function f of x is derivative can be differentiated, or is a derivative only if at a, so it can be differentiated at a if the derivative of f of x at a is equal to the limit as h approaches 0 of f of a plus h minus f of a all over h. So we are saying if, so using the credibility of limits, we are saying if a function is derivative at a, if function is a derivative at a or can be differentiated at a, we are saying it should satisfy the condition where the derivative of f of x at a is equal to limit as h approaches 0 of the expression f of a plus h minus f of a all on h. So it must satisfy this what expression. It must satisfy this what expression where this limit must what exist. So where the limit exists, where the limit exists. Okay, now let's take the next one we are looking at. So this is just differentiation with a glimpse of it. So let's take the next one we are looking at. So number 2, we are looking at tangent line. Tangent line. Now I'm not going to explain what a tangent line is here. If you want to have a fair idea of what tangent lines are, various forms of lines in maths, just subscribe and like and follow, because I'll be creating the next video on these lines, tangent lines, what they refer to, how they cut the various parts of the words, the Cartesian plane. So subscribe and follow. Okay, so we are looking at tangent lines. Now we are saying if y is equal to f of x, if y is equal to f of x, so at a point a, so at a, the y component of this a will be f of what? A. This is the y component of this a. So at a, this is the point, so a comma f of a. Now we are saying that this particular for the tangent line, if you have the points a and you have the other one f of a, when you put the a into the value that you get, we are saying that the equation for the tangent line is y minus f of a, which is equal to the derivative of, it's equal to what? The derivative of what? X at a multiplying x minus a, multiplying x minus a. So we are saying y minus f of a is equal to the derivative of what? X at a multiplying x minus a, multiplying x minus a. Now this matches to a certain formula. If you are using the formula, we want to find the equation of a line. You have y minus y1 is equal to m into bracket x minus x1. Remember this formula, right? Yeah. So you can see it matches to this. So that's the same concept here. So this is your y component. So y component, and this is your what? X component. So as you can see, so your x component drops here, your y component drops here, right? So only if you are giving what? The points. Only if you are giving the points and the what? The you are giving the points and the what's the name? The derivative. The derivative. Okay, so the next one, we move to product and quotient rules. So product and quotient rules. Product and quotient rules. This is the next one that we want to move on to. Now let's take functions f of x and function g of what? X. So the product simply means we are multiplying the functions. So the product is So the product of f of x and g of x is simply f of x times g of x, and the quotient of f of x and g of x is simply f of x divided by what? G of x. But we're not interested in just the multiplication nor the division. What we are actually interested here is we are interested in the what? The differentiation of the what? The product, and the differentiation of the what? The quotients. Now I'm going to show you something here. Pay attention. So we have f of x and g of x. We want to find the differentiable term or the derivative of this. So the derivative of f of x times the derivative of g of x. We want to find this. So this means the derivative of them. We want to find this. Now the derivative of this is equal to, now using the product rule, you first differentiate one function and not differentiate the other. Then add it to the differential of the other function and not the differential of the other. So you can see. So the derivative, so let's start the derivative of f of x multiplying just g of x, not the derivative, plus the derivative of g of x multiplying just f of x. So we differentiate one multiplying by the non-differentiable of another, plus the differentiable of another multiplied by the non-differentiable of what? Another. That's how it's done. Now let me open your eyes again. Now you can see that this is what? There's this. Now what if you are told to find the second derivative? So let's make things easier. What if, so let's take our f of x is equal to f and our g of x is equal to g. What if you are told to find the second derivative of the product? Now the second derivative of the product is simply f second derivative of g plus 2 times first derivative plus f the second derivative of g, like this. Now let's prove this one. So we want to prove it. So we know that the first derivative, that's f g, first derivative was equal to f g plus f, right? So f prime multiplying g plus f multiplying g prime. So that was the what? The derivative of the first derivative of what? The product of the f of x and the what? G of x. So that was the first derivative. So we want to prove this particular thing from this. We want to prove this particular thing from what? From this. So what do? So we have to differentiate this again. So when you differentiate this, you come and get f prime of g plus f prime g prime plus f prime g prime plus f g second derivative. So when you simplify this, you can see you come and get f second derivative g plus 2 first derivative of f multiplying first derivative of g plus f multiplying second derivative of g. as you can see. As you can see, right? So if you are told to find the third derivative, what do you think you do? Drop that suggestion in the comment section. Don't forget to follow and subscribe. Now let's move on. Let's move on. We don't have time. Let's move on. So now let's go to quotient rule. The quotient rule. So as I said earlier on, quotient is simply if you are dividing f of x over what? G of x. You want to know the derivative of this. You want to know the derivative of this, right? Now, there is something. If you are doing the quotient rule, there is something you can do. It's very nice that you can do. But first, I'm going to state how you use the quotient. So as I said earlier on, so the quotient rule, so the derivative of this, so f of x over g of x, the derivative is simply the denominator will be the g of x, that's squared. Then you first differentiate the top. So the derivative of what? F of x multiplying g of x minus the derivative of g of x multiplying f of what? X. Multiplying f of x. So this is actually what you'll be doing. This is actually what you'll be doing. So as I said earlier on, there's another way. There's what? Another way. Now pay attention carefully. Now as I said, to make things easier, let's make f of x to be f, and let's make g of x to be what? G, to make things easier. Okay. Now we have f over g. You want to find the derivative of f over g, right? Now f over g can be f multiplying g to the power negative 1, right? Follow me. That's right. Okay. So now we have this, right? So you have this. We want to find the derivative. So you can imply the quotient rule with this. Have you seen? So now, using the quotient, we have derivative of f multiplying g to the power negative 1 plus f multiplying. The dot here means multiplication, please. Multiplication. Multiplying. Now, we want to find the derivative of g to the power negative 1. So, first, we do this. So, negative 1, it's like we are differentiating x to the power negative 1. So, in that order. So, negative 1 multiplying g to the power negative 2 multiplying the derivative of the function itself. So, g, as you can see. So, I'm repeating myself. So, the derivative of f multiplying g to the power negative 1 is simply the derivative of f multiplying the inverse of g plus f multiplying, now you are differentiating g to the power negative 1. Now bear in mind, g to the power negative 1 is a function. It's a what? A function. So we differentiate is like we are differentiating x to the power negative 1 first. And after that, you differentiate the function itself. You differentiate the what? The function itself. So as you can see, you differentiate the function itself. So g, derivative of what? G. As you can see, the derivative of what? G. Now let's simplify this. Now this can be written as what? So the derivative of f over g. Now there's a negative here, so minus f. Now this can come derivative of g over g squared. Now we are not done. We can simplify this. We can what? Simplify. So now we have g squared over. Now we will get what? F prime g, right? Minus f g prime. That's, don't they match? Where now I told you earlier on that f is the same as f of x. So let's put them into it. So we have the derivative of f of x multiplying the g of x minus f of x multiplying the derivative of g of x all over g of x squared. Check. So understanding concepts about the product rule is the best, because if you have a quotient, you can simplify it in terms of what? Products, and solve it as such. So understanding concepts in terms of the product rule is actually the best. If you understand a concept in terms of the product rule, There's nothing that you can't be able to what. So as you can see, proven. Okay, so the next thing you'll be looking at, is the chain rule. Is the chain rule. Now, for the chain rule, it's as simple as that. Listen carefully. We are saying if f and g are both functions, f and g, they are both functions, are both differentiable. So if they are both differentiable, if both f and g are differentiable, and a function capital F is the composite, so this is equal to f g, that is, so the composition of f and g makes the function capital F. Then this f is differentiable, and it is giving us the differentiable of f at x is equal to the differentiable of f multiplying g of x multiplying the differentiable of g of what? X. Simple as that. Now you know that this can be written as f is equal to f into bracket g of x, right? This can be written like this, right? So that's the same concept here. So the differentiable of this composite function is what? First, you differentiate this function. So you differentiate what is in the what's outside the bracket. So differentiate this f of x separately. Then you multiply it by what? G of x. So differentiate f separately, multiply by what? G of x. Then you multiply it by what? The differentiable of g of x. You multiply with differentiable of what? G of x. You differentiable of g of x. Okay. So for this, let's take a simple example. So let's say f is equal to x squared and g is equal to 3x plus 5. So let's take this example. So we want to differentiate this. We want to differentiate what? The composite function of f and g. So the composite function of f and g would simply be what? Would simply be 3x plus 5 all to the power 2. 3x plus 5 all to the power. So the capital F will get this 3x plus 5 all to the power 2. When I want to differentiate this, we want to differentiate what? This. So what we are supposed to do is that we have to differentiate the f first. So the differentiable of this at x will be equal to the differentiable of f first. So the differentiable of f is what? X squared is what? 2x. So 2x to 2x. Okay, so we are saying you have to differentiate f of g of x, not this f of x. So sorry, f of g of x, please. Mistake here, so it should be corrected. F of g of x. So the differentiable of this f at x will be equal to the differentiable of the f of g of x, like this. So the differentiable of this will be what? 2 into bracket 3x plus 5 multiplying the differentiable of g of x is what? 3. So you end up getting the differentiable of this composite function will be equal to 6 multiplying 3x plus 5, the simplified term. So simplified and well factorized. Now someone might ask, how did I differentiate this? Very fast? Now, okay, let's look at something here. So we are looking for the differentiable of 3x plus 5 to the power 2, right? Now you approach this as if you are doing the differential of x squared. Now if you are doing the differential of x squared, first put this number down. So the 2 come here. Then you reduce this. So 3x plus 5 to the power 1, right? But the x, but you can't leave your answer like this, because the x, there's a number attached to it, so you repeat that number. So multiply, so you differentiate the 3x to multiplying 3. That's how I ended up. That's how I ended up with what, 6 multiplying 3x plus what, 5. 6 multiplying 3x, so 6 into bracket 3x plus 5. Check. Okay, so now let's move to another one. Implicit differentiation. Implicit differentiation. Implicit differentiation. So implicit differentiation. Now this form of differentiation is such that you are differentiating variables that are not supposed to be differentiated. So say you are differentiating with respect to x, but you're having u there. You are differentiating with respect to x, but you're having y there. So a typical example can be x squared plus y squared equals 2. And you are told to find the derivative of this, right? But you are differentiating with respect to what, x. So with respect to x, find the derivative of x squared plus y squared equals 2. Right? Now, what is supposed to be done is that first you have to compare the what you are differentiating. So x squared plus y squared equals 2. Right? Now, if we differentiate with respect to x, this is how we approach it. So x squared, so this is what, 2x plus, now if we differentiate this, you write 2y, alright, but you don't leave it as 2y. Why? You have to show a mark that you are differentiating with respect to x. This carries the authority, this does not carry the authority, so you have to leave a trademark. So multiplying the y over the x. So if it was x squared plus u squared equals 2, it would have been 2u multiplying the u over the x, leaving the trademark that we differentiated with respect to u, we differentiated with respect to y. So now you know that the differentiable of a variable of a constant is what, 0. So it's equal to 0. It's equal to what, 0. So hence you can move the 2x, so transposing the 2x. So when you transpose the 2x, so minus 2x here. So you want to transpose the 2x, so minus 2x. Then here to minus 2x. Right? So you come and get 2y multiplying the y over the x equals negative 2x, equals negative 2x. Hence, you come and get your the y over the x equals, and you divide. So these two cancel these two, so you come and get negative x over y. As simple as that. This is very simple. This is very what? Simple. As I said earlier on, this is what differentiation rules. And after I'm done with this particular topic, the next thing I'll be doing is I will be solving a lot of questions. So please subscribe, follow, and like for more. Subscribe. Now let's move to another one that a lot of people don't know. We call it the method of related rates. The method of related rates. Now this particular method, a lot of people don't know this particular method. That's the method of related rates. A lot of people don't know this particular method. Method of related rate. Now, what does this method of related rates say? It says that if two variables, so let's say a and b are my variables. So if two variables are related by an equation, so let's say a squared plus b squared equals c squared. Let's say this is my what, equation. This is my what, equation. So if two variables are related by an equation and both are functions and both are functions of a third variable. So you can see that a squared plus b squared equals c squared, right? So in other words, you can see that this a and this b are both functions of this c squared. So you know that a squared plus b squared will give you c squared, right? So you know that b squared will also give you what? C squared minus a squared, right? And you know that a squared will also give us c squared minus what? B squared. Now as you can see, the c repeats in what? Both equations. So that's the third variable we are seeing. But this is not always a form to take. I'm just trying to give you the glimpse or give you the form of what understanding to use here. So if they are related by a third variable, a relation can be found between their rates of change. So you find a relationship between their rates of what? Change. Their rates of what? Change. Right? As I said, follow, like, and subscribe, because on the last part I'm going to just expose many examples, many questions that people don't know. So if you want to know, want to be the best, continue, follow, and subscribe. Okay, so we are saying that this is the method of related rates. So you have to what? See, now in the method of related rate, you have to see the dependent variable, and the independent. Now, this explains it all. To depend on someone means to rely. So the dependent variable relies on other variables, and the dependent variable stands solely if the dependent variables are not available or are not there. Right? So let's take the steps for using related rates. So I'm going to write them. So the first step is to identify the independent variable. So you identify the independent and dependent variables and dependent variables. So you have to identify the independent and dependent variables and assign symbols to them. And what? Assign symbols to them. So and assign symbols. So various symbols to them. So if it is time, small t, capital T. Anyone you can use, small t, capital T. Now the next thing you have to do is that what? You have to find an equation that relates the dependent variables. So find an equation that relates the what? Dependent variables. So finding equation that relates the dependent variables. So find an equation that relates the dependent variables. Then you differentiate both sides with respect to the independent variable, not the dependent variables. So now you differentiate both sides with respect to the independent variable. So you differentiate both sides with respect to the what? Independent variable. Independent variable. So that's what you do. Now, you differentiate both sides with respect to the independent variable using implicit differentiation. So take note. You use implicit what? Differentiation. Now the last step. In the question, you'll be given values. You'll be given parameters. Now these parameters will guide you get a definite answer. A particular answer. So the last thing is that you substitute the given information into the related rates. So you substitute given info into related rates and you solve for the unknown rate. So in the question that we're given, there will be an unknown rate. There will be what? There will be an unknown rate. Now, As to solve and get a relation between the variables, as to solve and get a relation between the variables, then you're given parameters. So now, if you are given these parameters, you substitute these parameters into it, then you get your final answer. So, audience, this is the end of our differentiation rules. As I said, derivatives is a very broad topic. Derivatives, that differentiation is a very broad topic. Now, I'm going to segregate this into many parts. Many parts. Now, the last part will be the most interesting part. So I drop questions upon questions, questions that will blow the mind. So I'm telling you, follow, subscribe, stay tuned for other episodes on derivatives and differentiation. Derivatives and what? Differentiation. So then, it's bye.